Right, hello everyone. So today we are going to write um, some elf header parsing and dwarf info parsing. So before we begin, I guess we'll go over some of my notes. I made some notes on this. So basically on Linux and most Unix systems, a lot of like embedded systems and also like video game consoles use like the ELF format for their binaries. Um, Now the elf format is like fairly simple. It's quite well thought out in comparison to dwarf is well thought out. It's just very complicated. The elf header, basically every elf program just consists of like a simple header, and it has like some segments which store information needed for runtime. So um, we're not really interested in that right now for this sort of program. And then it has some sections which store information that is static for linking and relocation. And then in those sections, there's going to be like some debug info, debug abbreviations, and stuff like that. These are like the two sections we're going to be interested in parsing today. So that'll be like the first sort of step, and then after we do that, we'll start looking at this like dwarf stuff, which is much more complicated and requires quite a lot of work. But we'll see how far we can get. So we'll start by I guess like the reason why I want to write this is because I'd like to have like a simple program that you could query for information about like the types in your program, like the size of them, their any padding they have, stuff like that. Also like get a list of like all the functions your program's exporting, all the functions that remained in the binary, like after optimization, stuff like that. There's you can stitch a bunch of tools together to do that, but I'm not like super like they're most of them are too complicated and don't really get the job done very well. So but we have like readelf, for instance, to check that we're doing something useful. So let's just open some random binary here. Oops, that's not right. So if we use like readelf.h, we get like the header. So this is the first thing we want to sort of just be able to do, which is going to be like parse this and output something similar to this. So that shouldn't be too difficult. It's basically, this is like the start of the program. So if you actually look at the binary for this, the first 4 bytes here are this little elf header, and then there's a few numbers, and then it's padded to like 16 bytes. So there's like some of these means certain things, but they're never really used. And then we get into like the more meat of the header at byte 0x1, so byte 16. Yeah. So to begin with, let's start by writing a main program. So eventually this is going to support just like freestanding, because I don't really care about libc, but for now, to get started, we're just going to quickly knock something out in libc here. So and the main POSIX won't use most of libc either, but eventually. But to start with, we'll include standard IO and stuff for printing. And we're going to include a few things here as well, like standard int, and standard def to get some types. And the freestanding ones, we won't include this because the size of the types will be well known. Oops, got that wrong. Okay. And we'll do that, and we'll just return a 0. Oops, we'll open a build.sh because that's what I have bound to my hotkey in my editor right now. And we'll just do a clang -mark equals native -o 0. We're going to need to have some debug information in this binary so that we can inspect it. And we'll probably just use this for most of the writing. So to start with, we'll just inspect ourselves. That seems like the easiest. We'll call it elf inspect. And we will do main posix.c. Maybe I'll swap the order of this. Doesn't really matter. Oops. Okay. Let's see if we can do this from here. I'm not sure. It should work. chmod plus x build.sh. And if we do this, I think we built that. And if we do a little, can't really do this from here. So we will just do a little read in from, what's it called? What did I call it? Elf inspect. Oops, that's all right. Okay, I'll just close this and do that. I don't remember what I'm trying to do here. Elf inspect. Okay, so there's our hello sailor. So, before we start, we're gonna need a few like operating system. Let's actually just open the main elf inspect program first. Because I want to define some types here. So we're gonna have our standard arena. I'm not gonna do dynamic memory allocation because that's stupid. Beginning, end. Just define it like that. And we're gonna have our standard string type, which is just a U8 pointer data, to define these types in here actually. So we're gonna define uint8t u8, and then we're gonna need so we're probably gonna need the full block of these. We're looking at binary data, so not gonna get away without that. And then I'm gonna try using S signed types like this for this project. We're gonna need 64-bit as well, obviously. Really, this is what the type should have been called in C, but we're using crusty old C, so we do not get that. And then we're gonna have a few other ones here. Let's just align all these. So for memory sizes, we're gonna have like a pointer diff p, and it's gonna be an IZ. Let's align this properly here. And we could have unsigned memory sizes, but I don't think we're gonna really need that. We'll add that later if needed. And in here, for now, I'm gonna put this up here, but we will see about that after. We're just gonna include our elf inspect.c. And we're gonna go. So we're gonna have a U8 data, IZ length. I'll just call it len because I have a debugging. Or call this stir8. Well, len because I have a what's it called? Macro that I have like a GDB pretty printer that needs it to be called len. Okay, and we're gonna define a few things here as well. We're gonna find local persist. Probably we're not gonna need some of these things. global and a function. Not overloading these, overloading the word static with every random thing, which C likes to do, and C++. Okay, so next, what we need is a different macro here. We need the stir8 macro. Also, over here, we're going to do define count of A as size of A divided by size of A. And S8, stir8, it's going to be a macro that takes a C string, and it's going to return to you a stir8, where len is going to be equal to count of s minus 1, and data is going to be equal to s cast to u8 in case you passed a normal C string. Hey, Fonklime, how's it going? Yeah, so I don't know if it's like null program or if he got it from like Casey Muratori or those guys, but it's like kind of like the handmade style thing. But yeah, typing strings like this is like super useful, and it avoids a ton of bugs and useless copying and a bunch of crap like that. So it's a good idea to always do something like this. Okay, so now what we want to do here is with these types, we need to start defining some operating system stuff here. So we need like a function, we're going to call it os read entire file, and it's just going to take a char star, it'll probably take a u8 star, null terminated u8 star. That's the file name, and then that's going to return a stir8. And we are going to do that. So we need a file descriptor. We're going to open, we're going to pass this to char. It needs a name. And we're going to do a little stir8 result equals 0. And then if fd is greater than 0, technically equal to 0, but whatever. Who cares? Let's just do if fd not equal to -1. We're going to get a struct stat buffer, and we're going to do if, actually, let's do it this way. And fstat fd and sb is not equal -1. We are going to set result.data is going to be equal to mmap 0. Just remember here, let's get rid of this. So the address, the length, the size. So sb.st size. Protections, I'm just going to shrink this a little bit here. Protections, we just want reading permission. We don't need writing permission. And what's the flags? I forget what. I always just like have these. I never type this function over and over again, so I always forget everything. I think it's just private for us. And then I think it's the file descriptor. And then the offset. FD and 0 for the offset. If result.data equals -1. So map failed. In the POSIX layer, we'll use map failed, but it's just defined as -1. If it does not equal that, I mean, is actually what we want. If FD, sorry, not get distracted. If that, then we're gonna set the result dot len equal to st or sb.st size. And out here, if fd does not equal -1, we're gonna close fd. And we will return result. Alrighty. So we're gonna need to include a few things to get access to this. So I think open is in like some weird. It's not where you think it should be. Yeah. Well, I'm going to need this anyway, so we'll include it, but and then include. I think we don't actually need, or maybe some of the descriptions are in that. And I guess I need to actually specify some flags for open. But I forgot. Oh, read only. Oops. Okay, so I have done some dumb. I put an extra space there. This needs a semicolon. I don't know why these are all defined differently. Okay. And then. Oh, right. I'm already forgot I changed the name to S32. That's fine. Okay, so that builds. Now what we're gonna do is I don't know if we want to just make this available to, probably we want to make this available in the yeah, we're gonna do this like this. We're gonna define these prototypes here. Let's do a little note here. Platform API define here so that other platform symbols are not visible to this TL translation translation unit, sure. Sorry, OS read entire file. I wonder if I should just call it map file so it's clear that it's a mapping. Probably it is better if it's called map file. Okay, I'm just gonna take a U8 pointer. Okay, and then in here, I have a function. It's going to possibly return a status code, though. Sure, it will return an exit code. This can be called elf.inspect. It's just the main entry point. Yeah, I don't need to comment that. And right now, it's just going to take a stir8 file to inspect. Then we change this name. And we are going to do this. Stir8 file equals OS map file. Going to cast ourselves to U8, and we're going to do argv0. argc data pointer argv. And then we're going to call elf inspect with file. Oops. Okay, so right now elf inspect needs to return something. It's going to return 0. Oops, missed a semicolon, and there. So that should be good and working now. Now either I think what we're going to do is not open a debugger yet. We're just going to write we're going to try to just grab the header first and see if the header looks correct. So for that, we're going to define our own headers and stuff because I'd like to be able to do some more fancy things with them. But to start with, we will just copy the definitions from elf.h. Okay, this is a bunch of junk. It's kind of weird. We're going to need both elf32 and elf64, but they will be... I don't know why. I feel like this is not necessary. This ni dent, it's always 16, so I'm not sure what that's about. Just going to do that. Okay, so we want to be able to print these, so I'm going to do this a little differently here. Elf header, and it's going to take a members. This is going to be just a quick little X macro to help us with printing. And we're not going to use their weird types here, or their names for that matter. And this is going to take the size of a pointer on the platform. So I don't know if it should be like sized. I think it should just be sized 64. I did call that right, yeah. Okay, it's going to take a, I guess, yeah, it doesn't, good pointer size. Pointer type. No, it's like pointer offset. It's like pointer size. Size of the pointer for the platform, or for the header type. And then we're going to do some X macro magic here. I'm going to delete this one is a special. We'll think about that one. Yeah, that one's going to be special. So the particular goals is like I'd like to be able to just easily query, like, you know, just ask the program. So you give the program like a query for like a type in the dwarf in the debug info, and it would print that type with like the member sizing, stuff like that. Any like padding there was inserted by the compiler, and then it could do. I'd like to be able to do that, just very easily get that information quickly without like having to open a debugger and do a bunch of junk. And then also like just query other things like exported symbols and blah blah blah, which isn't necessarily needed. That's not really dwarf info isn't needed for doing that, but stuff like that though. Okay, so this is gonna take. Let's just put a comment here. X type, and then name Yeah. Okay, we're gonna do that. So it's gonna take a type and then the name, which is basically what we have here. So we're going to grab this and do this. Oops. And we're gonna grab all of this and do this and do X, and then that's a tab. It's annoying. I'm gonna fix this actually. I don't want that to be spaces. And then what we're gonna do is just go in here. We're gonna just do this like this. Oops. Elf.32 half is gonna be a U16. That's not right. Why are those called half? Let's have a look at the header again. elf.h. No, it is U16. Okay. That doesn't quite look right, but maybe it is. Oh, this is the size. Okay, yeah, these sizes maybe are not more than 64 kilobytes. That's fine. It was the offsets I was confused about. Okay. Yeah, so those are U16s. elf32 word is also no, it's U32. Okay. And then these are also these offsets and this adder are the ones that are special, which is going to be pointer size. I don't even know if you're allowed to do this with a X macro, but we will figure that out in a second. Align this U32. I guess all of these need commas. Delete that. We'll rename all these in a second. Oops, wrong one. Okay, so there's that. This last one doesn't need to have this. Calling this type is going to be dumb, but so let's not call that type. Let's call it size. C type. Just yeah, C type. Okay. Now it might be better to, well, no, we'll do this. Get scared of this, E, that's useless. Machine version entry. We could use, I guess we can keep these names besides that. So yeah, that's fine. We'll keep those names for now. And then, okay, so we don't need this. Like elf64, yeah, like this is like weird. I don't know why they did it like this. The address sizes are different, but that's the only thing. So okay, we're gonna delete that. And then we're gonna do a little bit of X macro here. And we're gonna do C type, name, semicolon. And we're gonna do type def, struct, identifier u8, and then elf header members e32 first. This is going to be elf header 32. All the ones we're going to be looking at right now are going to be 64-bit, but I'll just have this type here just in case, just for later. We'll do this. Elf header 32 and then U64, elf header 64. And we're going to have a little bit of we're going to try to make this a little bit more generic so we don't have to keep passing around stuff. So we're going to do type def and elf header kind. And we're going to have elf header kind 32 and elf header kind 64. Let's do this. We're not going to have more than that. I think there might actually be different ones, actually. Maybe not. There's like OS ABI stuff, but I don't think there's anything. I think it's only 32-bit or 64. Okay. Do that, and then we're going to have another struct here. It's going to be like the base elf header. And that's going to have an elf header kind and a union. Sure if I want to do like anonymous unions and make this require C11, or if I'm going to not do anonymous unions and not use C11 features. We'll start with making it not anonymous for now. And this is going to be a union between elf header 32 and elf header 64. So we're going to like waste some space on for the 32-bit header, but I don't really care. Okay. So now what we need to do is we have our file and we need to look at the first magic byte to make sure that we are an elf header, that we are an elf file, I guess. It's going to return like a Boolean 32. Okay. So first we want to check if we are elf header. So if file.data 0 equals 0x7f. So if you're wondering where I'm getting these from, it's right here, elf magic byte 0. So there's like there's something actually a little clever about this. So first of all, this elf identifier field, this first 16 bytes, these are all defined as like individual bytes. So if the elf header was compiled, like if the elf binary is from like a little endian or big endian machine, this first 16 bytes are always exactly the same. So you don't have to worry about like where it came from, which is quite nice because you want to be able to handle both like the big endian binaries and little endian binaries. So by making it like single bytes like this, you can just check without having to do any like weird byte swapping to determine what the order of the bytes was. But the rest of this stuff all depends on the byte order of the binary. So in this identifier, there's actually some information. This EI data, like this, it's byte 5, like at offset 5. This tells you if you're big endian or little endian. I don't know what this last one's about or what this is about. But anyways, these are probably not going to show up anywhere. And then based on that, you can determine if you are running, if the binary came from a little endian machine or a big endian machine. So we're going to support both, but for now, obviously, I'm on a little endian AMD 64 system, so I'm only going to worry about that. So if file data, let's put it this way, is elf equals this, or maybe it's even better to just put this into a little helper here, is elf. And this is going to take okay, and then we're going to say result file dot lan greater than 16. I don't know like what the smallest elf binary is, but there's actually like a size. But so we need at least the identifiers though to maybe this should even be size of. Then we have to get into like the. Let's say that this has to be at least 16 bytes. And then what we're going to do is say that 0 equals 0x7f. 1, 2, 3. ELF. Okay, so this is how we're going to determine if we're an ELF file. Is ELF file and then if we're an ELF, what we're going to do is call another function here, which is going to give us the ELF header. So function ELF header, this will just return us an ELF header. ELF header from file. And this will be like the function that handles swapping bytes and stuff if we were when we go to support and other endian machines. So we'll do that. Let's do this. So stir8 file. We're going to do this. Elf header result equals 0. We're just going to 0 everything. Okay, this actually might be a C11 feature. I don't know if you can do this in C99. If that's the case, I'm not gonna support C99 compilation, but because this is too useful. Anyways, okay, so what we want to do is actually look at this header a little bit and determine some things. I do wonder if we want to like well, in any case, what we'll do first is we're gonna just look at the fifth byte and determine if we're little endian or big endian for now. I guess the problem here is with this function. Yeah, okay, we're gonna do like an assert here. That's what we're gonna do. Yeah, we're just gonna do an assert condition. This is more like a debug type assert, but that's fine. I think, does this... I don't remember if this needs to be volatile or not. If C... this is like a bit annoying, but whatever. Platform specific. So in ARM, you use like a different instruction to break in the debugger. Anyways, so we're gonna start with that. This is like straight up null program stuff, but I won't deny that. That's like the best way of doing asserts though. So we'll do that. Okay, so we're gonna assert that file.data5. So first of all, we're gonna assert that file.size is greater than size of elf header 64. We're only gonna support this right now. And file.data5 is equal to, I think 1 is the right one. Yeah. So we're just going to assert that we're 64-bit header and that we are doing, and it's little endian. I could, we could make that into a constant for now. Elf header endianness. Elf endianness kind. Yes, I like that. Yeah, we're gonna have some eeks here. Big, little, I don't know what this none is, but we'll keep these, and I don't know what num is either. Elf endian kind. eq little. Probably I should just actually use the types here because, oops, that is not what I meant to do. Peace. Keyboard. Why? Why editor? Zero, 1, 2, 3. I'm going to use the specific constants there. And we also have to assert that the elf header class is. So we're going to do this. We're going to do the same thing again. I don't know what this like class none is. Oops. Two and ehk num. Oh, this is like a count. I don't know why they've defined this. I really don't know why this is defined in the header. It's just not, yeah, I'm not including that. I don't know why those are defined there. Okay, so the endian kind, and then we also need to assert in here. Let's just do it this way. Let's make this multiple lines here. And assert that file data 4 is ehk 64. Okay. And then since we've done that, and I don't care about doing the right thing right now, we're just gonna raw cast this. Are we just gonna mem copy it out? Probably. These things aren't that big yet. We're just gonna like mem copy this. Well, we're not gonna mem copy it. We're gonna make the compiler mem copy it. Okay, so then result dot find is gonna be equal to file data 4 and result dot u dot e64 eh64 is going to be equal to elf header 64 pointer dereferenced stir.data or file.data. We kind of have like kind stored twice, but do we actually need to do that? I'm not sure. Because it's in like the identifier. It's kind of more clear from like a debugger if you have a separate kind field, to be honest. And then we're going to return the result. And now we might want to step through this in the debugger and see what's going on. If is elf file. Get rid of this. We're going to do elf header equals elf header from file. Okay, we're just gonna do this for now, and see if we compile. Let me see here. File.len. And then assert not C. Okay, so yeah. Now what we're gonna do is open this in the debugger. Oh, I got my elf. I don't have the tab. Okay, so in here we're going to break at main, and we're gonna run it. So we're gonna grab this. We got a file. It's probably our own file. Let's see here. You don't need to see all that crap. Yeah, okay, that's good. And then we're gonna step into here. We are an elf. We're gonna step into here. Are an elf 64, and then our file type is this. So if we take a look at the result here, 64-bit elf, we're this one. So we're version 1. We've got a machine number here, which is which one? So this is OS API stuff. We want to go to the end of this, which is this. We're 3. We're an ET dynamics. We're a dynamic executable machine of 62 is x86 64. That's correct. So maybe we'll print this, and then we'll call the first section done. Version 1. I think we have to be version 1. If we're not version 1, it's a problem. I think there's no other version besides version 1. Okay, and then we have like the entry point. Is this the actual offset of the start? This might be the offset of start. We'll have to like hex dump ourselves and look. What is this? Is an X? Okay, that's like let's actually like hex dump this and look. This is the wrong way of doing that. Start 0x1780. So that's correct. That's the entry point of the program. Header offset is where the program header starts. Section offset is where like the section info starts. So I don't know if that's any of that's listed here without me dumping this separately. Anyways, so that's the one that we're interested in today, and we get flags, some elf header size, which is 64. I don't know why we need to know that, but because I think that's just size of this. But anyways, the header entry size, the number of header entries, the section entry size, and the number of sections is 33, and then section header start and index. I'm not sure what that one. I have to look at what that is, how that's supposed to be used. I think that's which section of these section numbers that contains like all the strings for the program. Okay, so that's pretty good. Let's try to print that to, oops. So this is gonna be probably have to refactor this, but for now we'll just do print elf header. So the reason why I had this defined as an X macro is so that I don't have to keep typing stuff over and over again. That doesn't mean we have to have a little bit of a, that's fine though. So we're gonna do a little bit of a switch on EH kind. Put a return there. Case EH kind default printf invalid elf header. Do we actually need to do this? I'm not sure. We also need to have like some OS fatal stuff going on soon, but anyways. Elf header kind 32, print elf header 32. And if it's a 64, we're gonna print elf header 64. So for print elf header 32, we're just gonna do nothing right now. It's nothing, and then for this one, print elf header. Actually, let's do it this way. Print 32-bit elf header. Let me see here. Why am I not in the mod console? Okay, so print elf header 32. We'll do that. So in print elf header 64, however, what we're gonna do is we're gonna use our X macro here. To do a little macro magic. We're gonna want to like pad this stuff eventually, but put these here just in case someone does something stupid. Basically, in case I do something stupid. So what we're gonna do is we're gonna do that's fine. Oh yeah, that's fine. We'll do print C type. First we'll do print f name :space. And we're gonna do print C type EH2 U dot name. we're gonna printf n. And we're gonna do undef.x, and then in here we're gonna do elf. We have to print the identifier as well. I'm gonna skip printing the identifier just because I need to do like a looper thing. Actually, it's fine. We'll do that. For u32i equals 0, I less than count of EH2 identifier. Oops. Identifier. Print U8 hex. Fire I. Yeah, we'll do that. I'm gonna do it this order, just because I'm lazy. Okay, so we're gonna do that, and we're also gonna do right, we can just use printf here. I don't need to write that function right now. Hello, Fern of Sigma. How are you doing? Let's actually do it like this. 0x space percent 02 x. Sure. Lowercase x. Living. That's good. It's good to hear. Okay, EH identifier. That should do the trick. And then what did I call this? Elf header members or something. Yeah. Elf header members U64. And now we will have to fix a bunch of things where it's going to ask me about some. Well, that's the first problem. The first problem is that I need to call this printf. Then I need to count of this is u dot eh64 dot identifier. U dot eh64 dot name. I think this is fine. eh dot u dot eh64 dot identifier. Okay, and then this is the ones I was actually expecting. So I don't have a print U16, I don't have a print U32, don't have a print U64. So we just need to implement those. I'm doing well. I haven't been streaming a lot because I'm trying to finish my master's program, but I just felt like streaming today, so we're gonna do some streaming. Print U32. We need to do U32 V. Exactly. Recreational programming is always a good time. So we got U16. I guess this should just call print. Should all just be U64, and these just other ones we'll just call that. Print U64 V. Print U32. Let's call the same thing. And then this has to be LU, probably. Or I think it's like, this might be ZU. Okay, well that compiled, so let's see what we can do here. Interesting. Why are we not printing anything? Oh, because I didn't actually call the function. Probably help if we called the function that does the thing. Okay, so we are hitting some assert that I obviously didn't handle properly. We're gonna do this, we're gonna continue until we hit the thing. Why are we in this function? Oh, because I didn't rename the code that I copy pasted. It's called this. Here, I can give you a quick link here. Okay. Should have used the cock pilot. Then my copy pasting would have been more efficient. Okay, there we go. So, I need an extra new line. Where's print elf header? Print elf header. I guess that's why I had the new line at the end. Anyways. All right, so that's the elf header from ourselves. I think it's pretty cool. We might want to like pretty print some of this stuff, like the type, all that stuff that can come after. So I think that's a good place to put for here. So elf header parsing 1:14:30. Forgot to mark the intro. And then we can go on to this elf section header parsing. So let's just do a quick little break here. And I'll just remember to chop this out here. So let us just do a quick little Do you use /marker? I am not an expert at how to do this the best, so I'm just gonna. Oh, you mean in Twitch? Yeah. No, I'm not. Actually, that's a good idea. I don't know if that would help me though. I'll think about it. This is mostly just for YouTube videos after, but I guess like maybe when you might be able to like export the markers from the video. That's interesting. I should look into that. Yeah, so we are just gonna do a little cat 5-minute break here. It's probably not gonna be 5 minutes. It's gonna be like me going to the washroom and pouring some coffee. But we will just do this anyways. Sure. Alrighty, so I will be right back. Before we just get started, let's just quickly look up what how /marker works. You can definitely get the markers using the API. Um, okay, it seems like it just shows up in the dashboard, so like it's actually seeming pretty useful. Maybe I will start using /marker. That seems smart. So we should actually do that. Yeah, that's a good idea. All right, cool. So let us continue then. Markers were a good idea. So this is going to be, I probably don't need to keep track of that now. I may or may not do this, but anyways, let us now, probably it's a good idea to make a little commit point here. I didn't even init this as a repo. I'm going to do like this, elf inspect. I actually, let me just check here. Did I actually leave a new line in there or not? Okay. So I'm going to insert my password to sign. Okay, so then we will do elf header dumping. All right, so that's not bad. Let us now go on to the section headers. So let's actually look at the notes here that I wrote. Right, so I didn't actually write that much about the elf header because it's kind of simple. So basically in the elf header, we have this field, what is it? Section header offset. And this gives you the offset in the binary data from the start of the file, I assume, to where the section headers start, the section header table starts, I guess is what I should say. The section header table has section header number entries, and each of those entries is sized by section header entry size. So shrink this down here. I think that we're in here. So section header has some stuff in it. I think it has to have X word. Interesting. And then I think that, so is this even useful then? Like, what did the section header entry table tell us? If we look at our own binary here, it says that the size is 64. So that would be 8, 16, 24. Sorry, these are 32-bit. So 8, 16, 24, 32, 40, 48, 56, 64. Yeah, I'm not sure this section enter. I don't know if this size actually matters. I feel like it's just gonna be, it's just another way, it's just another encoding that's telling you based on the type what the size of the thing is. So yeah, I don't know we need to care about that. So, but what we will want to do though is this section header number is going to be different depending on the binary. So, and you can have like custom sections in your binary. And that's actually one of the motivations for this is I was watching Mr. Fourth Dimension. See if I can just quickly find his video in my history. And I'll probably post a link to this. What is the... I don't know if this was the first one or the second one. Okay, well, anyways, I'll use this video as the example. Oops, that was the wrong thing to grab. So yeah, he was writing this C scripting thing where he's trying to come up with like a way of doing some, we'll put this as a link. Mr. Fourth C scripting. So this is like quite an interesting video actually, for people interested in this kind of thing. He's basically trying to use custom section headers to define structures or define like tables of structures that he can iterate over in C without actually having to build them at runtime. And to do that, he needs to make sure that the data section size is like a fixed size. It needs to be exactly what he's telling it to be, so that he can do some math to determine how many of those items he has. So anyways, it's very interesting. I think this is actually maybe the first one. C scripting, introduction, and to-dos. Yeah. So this is the first one. C script. Word looks weird. Okay. So we'll add that as a link later. So anyways, I might want to use that technique in the future of adding custom sections to my binaries. But so for now though, we know that this section header number is going to be different depending on the binary. And since we just hard coded this, I can just use read elf. So this should agree with. Oops. So if we do elf inspect and then we do read elf /h on ourself as well, this should just match what it tells us. So number of section headers, like this is all the same junk. Right, so what we want to do is introduce the arena into this program. Now, probably we're going to eventually have like some context for this, but for now we're just going to do this. We're going to do arena equals os get arena, os arena new. We're going to pass in a size here. I'm going to have a macro, not kilobytes. We're going to do megabytes. I don't know, like, since we're not caring right now, we're just going to grab 32 megabytes. It doesn't matter. The system has like 64 gigs. I don't care about 32 megabytes of memory. Obviously, we can like shrink this a little bit once we have a better idea of how big the tables are in the dwarf format, but let's open elf inspect here and add some of these macros that I need. So we need to define megabyte A is going to do U64 A, shift it up by 20. We're not really going to use that. Oops. Kilobyte is going to be shifted up by 10. Okay, so in here, we're going to have a little function. Arena. OS arena new. It is going to take an iz size. And what we're going to want to do is round this up to the page size, even though the one I've already got here is rounded to the page size, but just because we're good citizens, we are going to round it to the page size. So I don't know if I want to use get page size or not. I don't trust it. Well, we'll do it, but I don't really trust it, especially because there's two for some stupid reason. Can't remember which one of these you're supposed to use. Yeah, I don't know why these are different. We're gonna do one of these is correct and the other one's wrong. But I don't even know if it's like correct always. So I think this value is like hard coded in like muscle libc, which is what I'm using. Even on platforms like ARM, which can have different page sizes. So that's why I'm like kind of like whatever about using that. But anyways. is going to be size. We need to do size mod page size. That gives us the remainder if we divide by the page size. So then the padding will be size minus size mod page size times page size. I always forget how to do this math because I'm a dumb. Let me think here. So if we mod this with the page size, we get the number of bytes that would be left over. We want to take that number of bytes that's left over, and we want to do page size minus that. Get the difference, and then we're going to add that to the capacity. So really what we want to do is just do size plus equals this. Okay, now what we're going to do is we're going to do arena result arena it's going to be the same thing as before, mmap 0 size prot read write private -1 0, and then we're going to do result if result really I don't want to do this until we just do these. Okay, we're going to do this. PhD, I don't know, whatever. If mem does not equal map failed. Result dot end is going to equal mem plus size. And then we're going to return the result. This is kind of ugly. Do this. Okay. So that's going to give us some memory to work with. Now we're going to do some arena alloc function. We're over here. This is going to take the arena type and count. It's going to call, well, I guess this is the other reason why to use C11. Because you can't get the alignment of a type in C99, which is definitely something that should have been possible, but was not. I think we are just going to use C11, but anyways. So let's actually start writing this function first. Function void pointer. We're going to cast it to the right type. So this is going to be key pointer. Alloc. And it's going to take an arena pointer A and a alignment size count. Yes, that is what that is going to take. So we're going to do an align of here. And then a size of. And then a count. So this is also null program stuff. This is how null program does his arenas. Now other people like Ryan Fleury and like Rad Debugger, he uses a different, more complicated arena structure, and same with like Soding, that guy. He also uses like a more complicated arena. His arena is like a linked list of different blocks, different regions. We're just gonna use like the linear one. It's usually, let's put it this way, I've written like graphical programs that are doing just fine with the linear one without chaining blocks, so you don't necessarily need to be chaining blocks all the time. So anyways, iz capacity is going to equal a to end minus a to beginning minus uint pointer p a to beginning and alignment okay, and then we're going to do if what's it called, capacity minus padding divided by size is less than count, or whatever. Anyways. Important, very important. Interesting. I will read that email later. Let's see. So, okay, we have enough space, so what we're gonna do now is do a little bit of we should also have like a memclear function here. Memclear result 0. Result is going to equal a to beginning plus padding, and then a to beginning plus equals padding plus size times count. Yeah. Okay. So we're going to have a little bit of a memclear. We're also going to define the zero struct macro. I don't remember how I usually write this. I think I usually consider this to be a pointer. Anyways, so function void star mem clear byte and then iz size. Oops. So for izi equals 0, I less than size I plus plus. S0 si equals byte. Return s, which should literally be like this. Yeah, let's not complicate this. Okay, so we got this. We're gonna mem clear our thing. We got our arena alloc. So what we want to do now is in here. We got an elf header. Now we want to do is construct all the section headers. I don't want to do this here. Let's just make this a section. So we need to actually define the section header first. So we're going to use the exact same trick again. This here. Elf section header, whatever. Okay, so we're gonna elf.h. So we want to find that section header section again. We're going to copy paste this here. We're going to delete this. So we're going to do the same thing we did before, which is to take this and this. Yeah, we're gonna do this. We're gonna go in here. We're gonna do elf32 word. Actually, this is not the right. We should do this on this one because these X words. Yeah, these X words are 32-bit here. They need to be like pointer size. So we're gonna actually do it with this one. Let's delete this. It's not right. Okay. Why do I keep doing the wrong key presses? Do not do the wrong key presses. Okay. So elf64 word. Elf64 word is going to be changed to U32. The rest of these are going to be changed to pointer size. So X elf64 underscore star slash S. Oops. elf64 star slash X. Not slash X. Slash B. I think that's like word boundary. No. I don't know why I'm doing this. we don't need to do that. We can just do this. I don't even remember what the stupid what's it called? Regular expression is for getting to the end. Hello. Why are you doing that? Okay, there we go. We don't need this section header thing. So name is a little weird. Name is not a, it's like a, I think it's like an offset into the, this one might actually need the Wikipedia elf thing. Let me just do this. I don't need this image, Wikipedia. I don't know why you're on that. So if we go down here, what is this? Program header, section header. So yeah, offset to a string in this string in an sh third tab section. So this should be like not called name because it's a little weird. It's an offset to a name. Focus. Camera. Come on, camera. You can do it. I'll just be blurry because my camera's dumb. I just want to focus. There we go. Yeah, so this is an offset. This is not like calling this name seems dumb. We don't want to do that. This is going to be name table offset. And then shouldn't have actually closed that because I want to happen here. Okay, so we're gonna go back down here to the section header. So there's a bunch of types that we'll have to copy so we can see what type we are. There's some flags we probably need. Now this address. So this tells us where I actually don't. I don't know how this works with address space layout randomization. I don't think we need to care about this field. The offset should be the actual offset of the section data in the image. The size of the byte, so the size of the section, we do need to know that. Means the section index of an associated. Okay, this is kind of arbitrary data. This is also arbitrary data. This, I assume this is like the base alignment of the section. So if you go to load it, you need to know that probably. Okay, and then some other junk. So I'm gonna keep this open over here for now. What happened here? Come on. Okay. So I might want to rename some of this stuff. Like offset should maybe be image offset. Well, whatever. We'll leave that for now. Let's fix this alignment. Oops. Because I am persnickety about stupid things like this. And then what we will do is do the same thing that we did here. So take this X macro again, and we're gonna have elf section, oops, header names, and then we're gonna have elf we're gonna do that. Okay, and then what we're gonna do, so this doesn't have this U8 identifier field. And we're gonna do the same trick, I think, again, which is I wonder if I should like change this to elf kind. Probably I'm gonna change this just to elf kind. Let's do that. This is gonna be elf kind. Now I do wonder if we need to store that in the I don't know if we need this like sort of elf section. Yeah, we'll think about maybe we'll think about refactoring this later, but for now we'll do the same thing as we did up there. I am starting to see that there could be like a little bit of a we need to use a lineup, so I'm gonna get rid of that U. Same with up here. There might be a way of defining some. There might be a way of basically treating these as the same thing for printing purposes, but I have to think about it. Okay, so we've got this. This one actually is going to waste like quite a bit of size on 32-bit, but that's okay. Prefer 32-bit elf, that's fine. So what we want to do now is fix any compilation bugs that I've just introduced, which is oops, this is supposed to be elf section header. Right. Is in the macro, so it's gonna be a pain on button. Elf header right. So elf inspect needs to take the arena now. Why did that go there? I have to restart this because it is in the dumb state that I hate. Okay, so we're good. All right, so now elf section header. We know how many of these there are, so maybe you want to do like an elf section header pointer. Sections. Whatever. And this is going to be so we know how many, like this is just an array. So we're going to do extract. Let's do elf extract section headers. And this is going to take a pointer to the arena and a pointer to the header. Yeah, I don't see why not. Actually, let's do it differently. Yeah, we're gonna do this differently. We're gonna do EH or header dot section header number. Sections equals alloc and arena. Okay, let's do this with file. Sections. Section header num. Okay. Okay, we're gonna do elf section header, and then we're gonna do header.shm num. No, I'm gonna go back to what I said before. I need to just quickly make a small break, so I will be right back. Okay, so yeah, the reason why I want to continuing, the reason why I actually want to pass this in is because we need to know some other things from this header, such as the endianness and blah blah blah. So we're gonna keep this, and we're gonna go into here, and we're gonna do function elf section header pointer elf not extra elf extract section headers. We'll do this. Let's grab this, go here, delete, 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 delete. Arena pointer A, file, elf header pointer header. Result equals this. There's something interesting here. If we yeah, there's something a little interesting that we can do here. So all these field names are like the same between the two header types. And the size is the same. Feel like there's something a little tricksy we can do here, which will be maybe we'll do that after, but basically what we want to do is yeah, there's a way to split these up so that we can just not care about which type we're actually accessing. That's interesting. I'll have to think about that. In this union here, like basically what we actually want to do is put all the unsized fields. If we put all the unsized fields and then but then the packing's going to be off. I mean, that's fine. It just means you have to read it properly. You can't like rawcast the header. So if you were to read this header properly and not just rawcast it, then we can actually use all these types that are the same in this header. And then we don't have to do like this weird thing where we're going to have to like check everywhere. Like, we're going to have this kind field. Okay, well, I'll have to think about that, doing that after. It's definitely possible. Also, there's another tricksy thing we could do here, which is to take this identifier and shove it here, and then the rest of this is going to be packed after it anyways, so... let me just fix these compile errors quickly. We're not going to do anything with this. I just want to try something. I called this S8 because I'm dumb. Okay, we're going to do this. That should have compiled. Oops. So, okay, let's try this quickly here. I think what we want to do is, yeah, we're going to do that. Okay, this is a little funny that we're gonna do here. No, this is gonna be annoying. I don't want to do that right now. Okay, we're not gonna do that. Oops. Okay, we want that. Okay, so let's ignore that for now. But we do have to. We are gonna have to. I don't know if you can have different kinds in the same thing, but so regardless, we have to. We're just gonna do this again. What I should actually have is like a to do. Um, let me see here. This is like just gonna be. Let me think. Let me think. Is this fine? I think so. Let's do this. This seems fine to me. Just so that it's actually marked in the file. Okay, so we're gonna do that for now, and then we're gonna do for all right. So what we want to do now is loop over. We want to fill in this section header, probably in the same way. So again, we're just gonna like assert. Should probably make this into like a macro for accessing this field, but okay. So we're gonna do that, and then we're gonna do result I dot feel like we don't really need to store the kind for all of those. Yeah, let's not do that. It seems like a pointless thing to do. Because we already know what the kind is from the elf header. So we're not going to do that. We're just going to do this. But yeah, we're going to do this, and we're going to do so here we actually have to do something different. We have to do iz offset is going to be eh to so for this we actually want to use the section header size. So first of all, the offset is going to be eh to section header off plus eh to section header size times I. What's the thing called? It's called section header entry size. Yeah. sh and size times I. File.data plus offset. We should like, I don't know if we should have some. Let's do a little assert here. It should be an error, so but we'll just do this for now. Assert file.len should be greater than equal to eh. This is an offset, so sh off plus eh to sh and size. Times eh to eh64 section number count. So I want to assert that we have like that the file size actually is containing all the information that we're trying to read right here. So we're gonna do that. Yeah, we're gonna do that. Does that make sense? We actually might want to make that thing yeah, you know what? The section header, we actually do want that to be a struct. And what we want to do is actually include a string 8, which is the section name. So we're going to actually want to look up the section name. So we actually want to look that up. Which means we might want to parse the section header Let me just see here. Was it like section header? Where are we here? So there's like the section header name, which is the offset to a string in the SHR tab section, SH stir tab section that represents the name of the section. I think we have to figure out where the stir tab is first before we can do that. So we'll actually have to do 2 passes here. Or like a number of passes. So what we're going to do is do this, and we're going to say stir tab index equals, do this way. And we're going to have to do, so if like we need to make sure this, okay, yeah. So if result I dot sh64 dot, what's the thing called? The type I'm going to rename that to kind equals section kind stir table stir tab index equals I break. And then if stir tab index does not equal -1, we can loop, we can stir tab equals file.data plus result stir result stir tab index dot what's it, there's like an offset, what's it called, offset, so plus or dot offset. Okay, so we now know the base of our stir table. Then what we're going to need to do is do a we're going to do this loop a third time, and we're going to do I think they're like all C stirs. I don't think that, yeah, I think the string table is just like a bunch of C stirs. So I think what we have to do here is do result I dot name is equal to C stir to S8. We're gonna just assume for now that they're all well formed, and we're gonna crash if they're not. Which is gonna be stir tab plus result I dot, wait. So yeah, there in the stir tab there is a yeah. So that go back up here quickly and look at the header. This name table offset is an offset in the name table section. So you can just add that. Name table offset. That will give you the start of the string. And then we just need to quickly write this C stir to stir a function. I'll put that like way up here. Probably after those functions. Function stir a C stir to S8 C stir. And then we're going to do stir a result equals dot data equals C stir. And then for while C stir, if C stir, let's put a little safety guard here, while C stir plus plus, and then result, a typo here, result.len is going to equal C stir minus result.data. This is just C stir to stir len, basically. That's all we're doing here. Just wrap C stir len, but as I said before, this program is not going to be using libc forever, so whenever it's possible, we are going to be not writing stuff that uses libc. So anyways, and that should be all that we need to do here. So let me see here. We're going to get our section header. We need to define this quickly. Need to rename that to kind. I'm assuming there's only one string table, or maybe there's more. I don't know. Probably there's just one. Let's try this and see if this can help us here. So we need to go to our elf section header, and we need to find where these types are. And we need to CP this. And then we need to go up here. Yeah, we're gonna, oops. And grab this, we're gonna do some helper delio here. We're gonna make a bunch of cursors, delete that. Section kind. Of course, this is using tabs for some ridiculous reason. What happened there? Let's try this again, shall we? What I can do is actually do this. Oops, that was dumb. Be cool if this did not like randomly scroll when you did this, some of this operation. Okay, there we go. Oops, no join, get out here. fix it in a second. Type def enumeration. Section kind. Elf section kind, actually. And the reason why is because there's going to be ones in the dwarf, and we need to know what we're talking about. Okay, so we're going to do this, and we're going to do this, and we're going to do, what we're going to do here. I'm going to grab this all. And we're going to rename some of this so that it's more readable. Come on. Like, I like this stuff. I'll look it up after. I'm gonna do that. Make sure these are all uppercase. These don't need to be uppercase. Oops. Okay, so that is fine. We got elf section kind. I need a bunch of, let's actually do this again. Oops. Need a bunch of commas. Okay. So there is the elf section kinds. We're not necessarily caring about all of these. Feel like I can delete these. I don't care about those for sure. They're probably not showing up either. Just gonna delete those for now. Oh yeah. Thank you for stopping by. Good luck with your walk. Okay, so let's see here. So where's the errors? Identifier. Indentifier. Okay. Stir tab index. This is an S. This is ESK stir table. So, okay, so up here, we renamed type to kind. And then this is sh64.nameTable offset. Okay, so let us go back into the debugger. Scroll down here, and we're gonna break here. If this will load properly, it won't. Looks like I calculated some stuff wrong. I didn't actually make an arena because I'm stupid. What happened here? Good size here. Oh, that looks wrong because size mod page size should be 0. Yeah, right. It'd be 1023. And we want page size. In that case, we want to add page size minus 1023. And that would give you, so 1023 plus that would give you the page size. Oh, we don't want that. That's wrong. Page size. Of course, I would screw this calculation up as I usually do. So like really what this is page size minus this, which is just page size minus page size, plus this, which is just adding size mod page size. Is that right? So we want to add we're just gonna like we're just gonna do this. That's not what we wanted. Let me do the math correctly. So if you had like 1023, you need to add 3073. So to get to 3073, you have page size mod the size, which gave you 1023. Like you don't want to add an extra page. I'm just doing something dumb. Let's just do this. Okay, so first of all, oops, please break. Let's do that. Let's try this again. So step into here now. We should still have the right size, which is that. And then we're going to do this. And we're going to get a map failed for some reason. Why would that be? Just look at my other code where I do this normally. Pretty sure this is exactly the same code I've written like over and over again, so. Oh, it needs to like have map anonymous. That's why. Otherwise you can't, if it's not map anonymous, it won't make a, you can't do this. You can't pass -1 for FD if it's not map anonymous. Okay, so now we've actually got a memory, which is good. I'm gonna continue. Okay, so we got through to here. We know how many section headers we have. We obviously did something wrong here. Like, are all of the section headers like this? Sections 1. Oh, no, they're not. No, we didn't. Why is the first one null? Why is the first section null? I wish GDB was a better, like I wish I had like a way of actually printing what I wanted here. Okay, so we're gonna actually just print out the section header names and see what we have here, because I don't want to do this. Long story short though is that I think we extracted it properly. So let's do this. For header dot eh64 dot section header num. We're not gonna print the whole section yet. I think what we're gonna just do is print the name. Let's do this. Section headers sections. Let's do that. If sections I dot name dot len printf percent dot star s, and then we're gonna do, let's do this, sections I dot name dot len. Let's do this. Stir8 name equals this. If name.len this needs to be cast to an int. Okay, let's take a look. Does this compile? Oops, Okay, there we go. So, that doesn't look quite right. So I have to fix that. I will be right back. Yeah, I thought that the issue is like some of this looks like partially correct. Oh no, you know what? No, these are not. These are not anywhere near correct. This is like libc start main. These are like actual functions. These are not these are not the section names. So if we do like readoff.sections on ourself, like what I was expecting was stuff like this: .interp, .dinsim, .text, .init, .fini. This also prints like the type. It also looks like there's multiple stir tab. There's like din stir. That's annoying. This is the stir tab I was thinking. It's like the last one. Is there any way? Ah, right. So the elf header actually contains some of this information. So let's just run this quickly. Let me get rid of this one. So here in the elf header, there's this. This is the stir table index. This is the actual one that we wanted, not that other one. Now that other one is also weird, but actually, no, never mind. Everything else there is just a bunch of garbage. So we're just reading garbage because the what's it called? These name table offsets are in the actual name table, not in some random other string table. So that would make sense. I wonder if I can quickly modify my build command to just output this to where I want it to. Let's do this. Elf inspect. I don't want to remember what the actual file descriptor thing is. This will get the job done. Okay, so this will give us everything in this so that we can actually see what's going on here. Okay, so here we don't need to do this. Don't need to do this. All we have to do is do this, and the stir table index should be 32. And I think we had 34. Okay, so presumably we can just do eh.eh64 dot stern dick. Why is that called that? sh stern. I don't know. Yeah, that should be that. That's correct. Okay, this is correct. I don't know why like the first section is 0 though. I'm not sure what that section's about. But that is pretty good because this is what we actually need to do the dwarf stuff. So we will in the long run, probably what we want to do is do some sort of hash table. I mean, this is like going to be short, and we're probably only looking up one or two, so maybe we don't do a hash table. Yeah, I'm not sure. Section header stir tab. And there's an actual stir tab, which is the string table, which is like the actual strings in the binary. That makes sense. Okay, so let's take the win there. section header parsing. I don't think we need to print the section headers just right now. They're not that useful right for what we're doing. But we will actually, like, what information is there? Like, I think let's just look in the debugger quickly here. Let's go here. Okay, so in the section headers, we're gonna not look at that one. Which is the stir tab. We have some information. We have an offset, a size. So actually, like, I think we're gonna skip it. We're gonna go straight to starting dwarf, but because we could build like a table of the section header, like the section locations. And print that, but I think we're gonna not do that right now, and we're just gonna go straight to the dwarf stuff. I should probably make like a break to make some tea as well. Okay, so section header parsing. That's pretty cool. Yeah, so the next thing we'll have to do is we're just gonna do like a quick string search over all these section names for the entry for the debug info and the entry for the debug abbreviation. I'm not 100% sure what the rest of these debug parts are, but I just know that to start with dwarf, we at least need these two. We might need some more. So yeah, we want to start. We want to just start the dwarf stuff. So we need to like get a. We need to get to. So the debug info contains all the dwarf CU headers. CU is yeah. So sorry. CU is compilation unit. It means dwarf compilation unit. Which is not really clear what that is from the documentation. But long story short is that each of these will contain like a tree of data. We'll look at my notes when I get back, I think, or we'll leave them open. So let me do another. So let's say here we are done this. We're at 257. And we are good. So let's add a little thing, and I will be right back.